Hi everyone, thanks for joining. Welcome to this session on how to leverage Redis and Kafka to process time series data. My name is Abhishek Gupta and I'm a senior developer advocate at Microsoft. And I tend to focus a lot on technologies like Kafka, open source databases, Kubernetes. So what's in store for you today? Obviously, I'll start off with a quick introduction just to set the right context, and then we'll dive right into the demo. Yes, that's what we are going to do. And finally, I'll wrap up with some additional resources and some food for thought. I do want to call out that although this is around this talk is around Redis time series, but it's not a deep dive. So at the end of the day, what I'm looking for you to is for you to take away how to use Redis time series in the context of a larger solution, right? So that's the whole idea here. And of course, all the artifacts associated with this talk, the code, the demo that I'm going to show you, it's all available in this GitHub repo, which I've represented in the form of this short link. So if you think about time series data, it's essentially everywhere. So think about weather data, stock trades, sensor data, IoT from your wearables, refrigerators, whatnot, right? But if you think about it from a very simple point of view, you can assume that it's sort of a tuple or a pair. So it's a single data point, and each data point consists of a time or a timestamp and an associated numeric value. And if you collect many such data points, that's what typically you would call a time series data. So before Redis time series, of course, we used to resort to sorted sets. And then with Redis 5.0, we used to use Redis time series to manage and handle and process time series oriented data. But now that Redis time series is here, I mean, it's been there for, I think, approximately a couple of years now. But thanks to Redis modules, it is now a first class data structure within Redis. Here are some of the basic Redis time series commands. So one of them is, of course, how do you, just like any other Redis data structure, right? So there are commands for you to create a time series, say ts.create, and then you can add data points to these time series with tsadd, tsmadd, and then you can query your time series as well using a simple commands such as ts.get and ts.mget, and slightly more advanced queries with range queries with tsrange and ts.mrange. And you can, interestingly enough, you can also aggregate your time series data. So things like min, max, count, sum, average are available out of the box. And if you want to, you can also create rules out of the box so that these aggregations happen out of the, by default, without you actually executing them each and every time. And as expected, there are a lot of client libraries for Redis time series. Java, Go, Python are just a few of them which I've mentioned here. So to be honest, Redis time series is not the only database out there, right? There's, you might have heard of InfluxDB and TimescaleDB, which is a Postgres extension. If you're in the time series world, right, you may even have used these solutions. But the truth is that databases are, at least in my opinion, just a part of the solution of handling time series data. Now, by nature, time series data is simple, right? It's a timestamp and a numeric value. How hard can it get? But if you think about it, it's high velocity. It's fast data, right? Tens of hundreds of metrics from different sources per second, and over the time, this is not just high velocity data. This is also a big data problem because all this data just keeps accumulating over months and years, right? So really my question is, or something for us to think about is, how do we aggregate and collect all this data and send it to Redis time series at the end of the day, right? One of the obvious answers is, hey, let's just dump it all in Redis, right? It's obviously our database of choice and it's lightning fast. And I have nothing against it. I'm sure people are doing this in production, and you can try that as well. But I think at the crux, the solution is, or efficient way of doing things would be to create something what you call a data pipeline, which is an end-to-end system to be able to ingest all this high velocity data, and at the end of the day decouple your sources, your producers, from the consumers as well as the end system. The end system in this case happens to be Redis or Redis time series. And the system can hopefully, again, like I said, decouple these producers and consumers and also act as a buffer. And that's where I think Apache Kafka comes into play, where I think it can play a very central role in building these data pipelines and data ingestion solutions. All right, it's time to dive into the demo. So let me just summarize the demo scenario here. So I have created this hypothetical use case, of course, right, wherein we have a device monitoring problem at hand. There are multiple locations, and each of these locations have multiple devices there, which we need to monitor. And in this case, we are just taking care of temperature and pressure. Okay, so I have simulated data to represent the data points of these devices, and I'll show that to you in a bit. So the name of each of the time series has a particular format. So if you see here, it's metric :location : device. So for example, and not to forget that there are more importantly, there is additional metadata or labels associated with each of these data points, and that is the metric itself. So is it temperature or pressure, the location, and the device. So just to give you a few examples of how you would hypothetically, or how you would add these using the CLI, for example. So to add the temperature for location 3 and device 2. So device 2 in location 3, you would say ts.add temp : 3 : 2, and the star represents the current timestamp, 20 is the reading. It's just hypothetical, just demo data. And the labels which we are adding here in this case is metric, which happens to be temp, just short for temperature, location, which, like I said, location number 3, and device number 2, right? And the same goes for pressure. So pressure : 3 : 2 represents the pressure metric for device number 2 in location 3, right? So I hope that makes sense and helps set the context in terms of what you want to see in the demo. Now, before I jump into the demo itself, let me give you the high-level architecture. So on the left-hand side, I have my local development environment. And this is, of course, just set up for convenience purposes. In a production scenario, of course, it's going to be different. So I have just a simple bash script, which is generating this fake simulated device data. I have a local MQTT broker running as well. So the script actually uses the one of the Mosquito MQTT simple CLI commands, mosquito_pub, to continuously generate data to this broker. And I also have a locally running Kafka connector, Kafka MQTT source connector, which keeps pulling data from this MQTT broker. And now we move on to the Azure part, the cloud part of the demo on the right-hand side, wherein all the data from the Kafka connector is pushed into a topic within a Kafka cluster, a Confluent cloud running on Azure Marketplace. And this high-velocity simulated data is processed by a Java application, which is based on the Spring Kafka library, and that itself is running. So there are a couple of instances of this application running within Azure Spring Cloud Service. And this just processes this continuously generated device data from Kafka, and then what it does is uses the Java client for Redis time series to finally push this into Azure Cache for Redis, which I have set up, the instance which I have set up, and this has Redis time series module running within itself as well. So that's the end-to-end, a very, very high-level 10,000 feet overview of what the end-to-end architecture looks like. Now let me go and show you the Azure Portal and some of the other areas as well, just for you to get a better sense of what's going on here. So now I'm in the Azure Portal, and this is the resource group, which has all the components. Now this is the Redis time series or the Redis instance here. If I click on it, I can browse here, And if you see, nothing special. I mean, I just want to show off this Redis Enterprise instance right here. And like I mentioned earlier, I also have an Azure Spring Cloud service here. So this is the Azure Spring Cloud instance. And if I were to go to the apps list of apps here, you would see that I have a single application, which is called Device Data Processor. It's a Java 11 app using the Spring Kafka Java library, and it has a couple of instances running. If I were to click on it, you should be able to see those instances as well. So you see there are two app instances running right here. Yeah, with that said, let me also quickly show you, just quickly run through this Confluent Cloud cluster on Azure Marketplace. If I were to go here, so this is the Kafka topic which I was talking about earlier. It's called mqtt.device_stats. So this is the topic where all the data gets sent to. Now let me go back to my IDE and show you some of the local components which are running. So don't worry, I'm going to share this. This is a part of the GitHub repo, which you can access later. So just to give you a quick snapshot of what the setup looks like. So of course, I just showed you the infrastructure components, the Redis instance and the Kafka instance on Azure, but we also have some local components and other source systems. So for example, the MQTT broker, and the local Kafka Connect cluster. So let me show that to you right away, real quick. So if I were to, so if you see, I have a few, couple of, a Griffana service, of course, for dashboarding, and the MQTT Mosquito broker running right here. And here I have the a Kafka Connect connector instance for MQTT source connector also running and operational. And this is, I know this kind of looks crazy, but this is simply a data generator script. Let me show that to you as well. So this just generates, random data. Like I mentioned earlier, if you see, this is just using the localhost instance of my MQTT broker, and really all it is doing is generating, random numeric values for temperature and pressure, and using this CLI command to, just continuously pump data so that I can build all that, I can show off a nice demo basically. So that's the whole idea. Okay, now let's see things in action. Now let me log into my Redis instance here. So Redis CLI. Okay, so now I'm actually connected to this Redis instance on the cloud, which I just showed you. Let me run a few commands here. So as you just saw, the data is continuously getting generated. We have the connector running. So, and we have the, actually, I should have shown you the Azure Spring Cloud, the device data processor applications as well. So I'll show you the logs real quick as to what's going on. Okay, so I have two instances running, and I just have this quick shortcut command just to show you those logs. So like I said, I have two instances. So let me show those logs to you right away. So this can take maybe a few seconds to come up. So yeah, you see, like, again, crazy stuff going on, continuous data processing, happening. So let me actually stop these logs. Maybe you'll get a better sense of what's going on that way. So all that's happening is, it's basically an end-to-end pipeline. So as soon as the data gets generated to a Kafka topic from my local Kafka Connect cluster, these application instances kick off and start pushing this time series data to Redis. So if you see adding temperature, adding pressure, so on and so forth. I have two instances. I could have multiple instances running as well. So that really depends upon the number of your Kafka cluster and topic setup. Yeah. Okay. With that, let me move on to the Redis CLI and show you run some of the the Redis time series commands, just to show you how the query process looks like. Right. So like I said, we have locations, we have devices. So what if I wanted to get the pressure for device 5 in location 1? Right. So I can use this simple command ts.get, and the format, if you remember, I mentioned the format earlier. So this is the format or the naming convention for our Redis time series. So this represents the pressure for device 5 in location 1. So this gives us the latest value, right? And this is going to change if I were to, just query this constantly. So this is the timestamp and this is the value for the pressure. The same goes for temperature. We could query for temperature for device 5 in location 4. I mean, it's the same, right? But let's move on to something interesting, because this is not very useful for us purely from a requirement and a use case perspective. So let's try filtering. Let's try using those metadata, those labels which we had pushed in along with our data. So let's use ts.mget. So we are going to fetch data for all the devices from location 3. Okay. So this is going to give you a lot of this is like a complicated response value, but let me break this down for you. So this gives us information for all the data in all the devices in location 3, both the temperature and pressure readings. But the problem here, or the constraint here in this case, is that we only get the latest or a single value, just like ts.get, right? So let's try to improve this situation a little better. So let's use the ts.mrange command. Now we can extract the temperature and pressure for all the devices, for example, in multiple locations. And more importantly, this is within a specific time range, right? So I have used minus and plus. This is like from the beginning up till the end, or the latest time range, but you could have your custom time range here. Right, so let me just do this for location 3, for example. Right, so you'll get a lot of time series returning, because you have a lot of data here, because data is being continuously generated and processed. But this gives you or demonstrates to you the power of mrange, right? And things are going to be much clearer when I actually show this to you in the form of a dashboard. So just wait for it. Just be patient. I'll get there. The same thing. You could run this for a specific metric. So I am only interested in temperature, for example, in location 3 and device 2. Sure, I could do that. So yeah, if I run that again, like I said, lots of data, you may not be able to make sense out of it, but just bear with me. And the interesting thing is, all this can be combined with what I mentioned earlier, the power of aggregations. So to reduce these large amount of time series data, you can say, hey, I want to aggregate an average over 10 seconds, right? For the temperature of all the devices in location 3. Sure, let's try this. Okay. And again, lots of, data in response, but if you see, this is much lesser compared to the earlier ones, because this is now aggregated. We have an average over 10 seconds rather than each and every data point, time series data point for all the devices in location 3, for instance, right? And you could combine this in various ways. Okay. Now let's go to the interesting part. Let's check out the Griffana dashboard here. Okay. So I have this running locally, like I said, on localhost 3000. Now, I wanted to start off with this dashboard here. So this is what you see right now, a continuously refreshing dashboard for temperature. Now, I'll give you like a few seconds to at least enjoy this dashboard. Like, we all enjoy dashboards, like we all like real-time dashboards. So so this is a temperature for a specific device in a specific location. Right, so this just uses a very simple ts.get command. Now let me show that to you. If I were to show the configuration for this dashboard, if I click on the edit button here, you should be able to see this. So thanks to the Redis data plugin for Griffana, this is all based off of that. So this is Redis time series. The command which I'm using to generate this dashboard, like I said, is the ts.get command, and this is the key which I'm using. temp:3:4. So device 4 in location 3, right? And this is a streaming query. This is like a continuously refreshing query which I have right here. So I have temperature. In this case, I have examples for pressure as well. The same thing basically. But what I want to show you is also the power of aggregations and how you can use them to build similar dashboards, for instance, right? So if I were to talk about the average pressure, for example, and the dashboard here, and let me quickly show this to you first. So this is over last 30 minutes, and Of course, this has been continuously refreshed. This is not a streaming one. This is a manually refreshed dashboard every 5 seconds. You could configure this. Yeah, just to keep things a little different, because last time you saw a streaming dashboard. This is a manual one. So this is over last 30 minutes. You could choose your time range. It doesn't really matter, right? So in this case, again, if I were to click on edit and show you the actual command being used here. So last time you saw ts.get, which was of course very simple. Now this is ts.mrange. I just showed this to you in the Redis CLI, but in the dashboard, this is going to make much more sense to you. So what is the filter here? So ts.mrange requires a filter. It cannot work without it. So the filter is, we have like multiple sort of angles here. So I'm choosing, hey, I want to focus on location number 1, device number 5 in location 1, and the metric I'm interested in is pressure, right? And this is being aggregated. I'm applying an average over a time bucket of 30,000, which is 30 seconds in this case. And that is what is giving us this nice dashboard, this nicely refreshing dashboard over time. I can show you another example of one final dashboard which I have, which is similar. It is now an aggregation for temperature, but the interesting bit is that it now covers multiple devices in a single location. And of course, you could have multiple permutations and combinations of this. I'm just showing you a few just because of time constraints. So yeah, nice little dashboard. The same thing, it is sort of auto refreshed every 5 seconds. We are looking at it over a period of last 30 minutes. If I were to go into the edit section here, you will see that I'm interested in the temperature metric in location 3 for multiple devices, device 1, 2, and 3. Right? So yeah, that was the demo for you. So just to give you a real quick recap, we have this local environment which is generating simulated data all the way, which is being consumed by a Kafka connector, and pushed all the way in real time to the cloud, where the device data has been processed by a Java application on Azure Spring Cloud, and finally being pushed to Azure cache for Redis, which is of course has a Redis time series module, and that can give you the power to continuously query and analyze all your time series data. Okay, now let's discuss some of the additional considerations. So I may have not touched upon these specific points in my demo and previous slides, but you should definitely take care of these Redis time series specific points. So one is the retention policy. Now, do you really want to retain all your time series data points in Redis indefinitely? Probably not. If not, so you should think about retention policy, because by default, the value for retention policy is 0, which means that none of your time series data points actually get deleted or trimmed. So take care of that. And as far as aggregation, compactions, and downsampling is concerned, now you can actually use aggregations in an ad hoc manner when you execute your range queries. But I think what's better to do is actually create rules with the command ts.create rule. So for example, if you see here, so what I've demonstrated here is ts.create rule, and the first parameter is the source key or the source time series. The second one is the destination time series. And what I'm trying to do here is, aggregating it as per average over a time period of 30,000, which is nothing but 30 seconds here, right? So at the end of the day, if I execute this rule, all the data points or time series data from the source key will be aggregated into the destination key. And only the data points over a span aggregated as an average over the span of 30 seconds will be pushed to the destination time series key, right? And last but not the least, you should also care about, what if you get duplicate data points, which I think you're very likely to get, to be honest. So how do you handle these duplicate samples? Now, there are various policies which you can put into place. There are, the default one is something called block, which says I'm going to just, Redis is going to return an error to you, but there are other options, like first, last, min, max, sum. So For example, if you were to configure first as your duplicate data policy, what you're saying is, hey, just ignore the new value and just keep the last value corresponding to that timestamp. When you configure, say, last, you're saying, hey, ignore the keep the current value and ignore the last one. And the same goes for things like min, max, and sum. You did see a Grafana dashboard in the demo just now that was, powered by the Redis data source plugin for Grafana, but there are other visualizations and other interesting integrations as well. One of the prominent ones is with Prometheus. So you can use the Redis time series adapter to integrate with Prometheus, and also Telegraph, which is a component of the tick stack. If you've used or heard of InfluxDB, so there is a plugin for Telegraph, Redis time series plugin for Telegraph as well. And finally, I've just clubbed, what I call these other considerations, which are important as well. So if you think about your end-to-end solution purely in terms of scalability, right? So your time series data can only go one way, like literally it can go up. You can only keep accumulating time series data, right? If you are implementing any production grade scenario. So you do need to think about the scalability, and I'm referring to scalability purely in terms of infrastructure here, the core infrastructure. And in this case, I mean your Redis and Kafka. And that's where I think, these managed cloud services come in really handy, wherein, they kind of, you're almost hands off in terms of taking care of the infrastructure, patching, and so on and so forth. And you can focus on implementing your solution and the business logic at the end of the day. They're not the only way to go, but yes, managed services can save a lot of hassles for you. And another important point to think about is long-term data retention. So I just mentioned in a couple of slides back that you would need to either think about trimming your time series data, aggregating them, so on and so forth, right? So you don't end up accumulating these in Redis. But you may want to actually retain this for the long term. Think about, having this raw data available to you, say, for example, to run machine learning algorithms. Say you're collecting time series data from sensors and devices, and you want to have these intelligent algorithms to run, say, predictive maintenance and so on and so forth, right? So you have to think about long-term data retention and cost-efficient storage mechanisms such as Azure Data Lake Storage or S3. These cloud-based object storage are kind of the ideal sink or destinations for long-term for storing your time series data in a long term. Just a quick note that there are existing connectors which can sort of help make this more seamless. At least from Kafka integration standpoint. So on one hand, you'll be pushing to time series for constant aggregations and queries in real time versus storing and retaining this data in cheap, efficient long-term storage. And finally, also in terms of integration, as you might have noticed, I had written a specific application, Java application, and deployed to Azure Spring Cloud to connect Kafka and Redis, right? But there are other ways of doing this as well. Potentially from a community standpoint perspective, I strongly believe we are missing what we call, these Kafka connectors. So I think if it's of value to you, feel free to ping me. Maybe I can work on it, or, as a community, if we can get together and think about it, I think that'll be super helpful. All right. So, what are some of the key takeaways? Of course, you can Redis. You can use Redis for almost everything, including processing time series data. But I think you also need to think about, like I mentioned earlier, right, the end-to-end system or the end-to-end data pipeline from your source, from all these time series data points to Redis time series as well as beyond for long-term data retention. And of course, not to forget the Redis specific aspects like data modeling, which applies to pretty much each and every Redis solution you build, and things like downsampling, data retention, duplicate data handling, and so on and so forth. And some of the next steps and resources, be sure to check out the GitHub repo, which I've mentioned here for, like I mentioned earlier, the code and the step-by-step instructions. If you want to recreate this demo for yourself and try things out on top of it, feel free to do that. And you can also check out some of the documentation, official Azure documentation, if you want more information on Azure Cache for Redis Enterprise, which was actually used in the demo which I showed earlier. So that's it. Thank you so much for attending. I hope you enjoyed the session.